All right, so you're going to review some percents, how to solve some percent problems, strategies that you could use. Your confidence should really be pretty high because the good news is you've learned everything we're going to go over last year. You learned it in sixth grade honors. So you're just using this as an opportunity to refresh your memory, to review everything you've previously studied, learned about percentages. All right, here we go. Which of the following could be the value of x? Choose all values that work. Read the inequality at the top. Read it out loud to yourself. If you read it correctly, the inequality says 3/5 is less than x, which is less than 67%. We'll break that down, make that a little more logical. Basically, you're saying x can be any number, any value, as long as that value is greater than 3/5, but less than 67%. Well, even still, that kind of just feels like, okay, what? Well, that's probably because you're thinking a fraction and a percentage. Kind of hard to compare those two. What strategy could you do to help compare those two? Okay, hopefully you realize, oh, I could just convert them to the same form. I can make them all fractions or make them both fractions. Sorry. I can make them both percentages or I could make them both decimals. If you made them both decimals correctly, then you would get 3/5 is equal to 6/10 and 67% as a decimal. Good, I hope you got that right. You should have gotten 67 hundredths. Now I'm really just saying x can be any number as long as that value is between 6/10 and 67 hundredths. Once again, your brain might be saying, wait, what? X has to be what? Well, remember, to compare these two decimals, you have the option of using placeholder. What placeholder am I talking about? You know, 0 is our placeholder value. So really, x can be any number as long as that number is greater than 60 hundredths, but less than 67 hundredths. Now I can start comparing. Okay, look at your answer choices, A through H. Step 1, find all the ones that are not already decimals, convert them to decimals. All right, let's go. B, 2/3 as a decimal if you did it correctly. 6/10 repeating. D, 5/8 as a decimal. 625 thousandths. E, 7/10 as a decimal. Well, you literally just said the decimal, 7/10. And H, 6 7/10% as a decimal, 67 thousandths. Now you can do a much easier comparison for all 8 answer choices to see if each one falls within that range. Greater than 60 hundredths, but less than 67 hundredths. Okay, start with letter A. 55 hundredths. Does it fit in that range? No. A does not fit in that range. B, 6/10 repeating. Well, that goes to the tenths. Our values are in the hundredths. So again, use that same strategy. Make this value go to the hundredths. Should you use a 0? Placeholder. Okay, hopefully that answer was no. That's a 6/10 repeating, which means the next value, if I continue that pattern, is another 6. So does 66 hundredths fall within that range? Hopefully you saw, yes, it does fit in that range. B is an answer choice. I don't know if it's the only one though, so I got to keep going. C, 6/10. Same strategy. Use your placeholder. Put a 0 placeholder behind it. 60 needs to be between 60 and 67. Well, it's not. X must be, according to our inequality, greater than 60 hundredths. C is not an answer choice. D, 625 thousandths. Again, same strategy. Since that goes to the thousandths, then simply take those two values we have in our inequality and make them go to the thousandths as well. Now I need to see, is 625 essentially between those two values? Yes, it is. 625 is within that range, which is why D is another answer choice. Good. E, 7/10. Same strategy applies. Use that placeholder, 0. Now I'm looking at 70. Is 70 between 60 and 67? Well, no. 70 is not between 60 and 67, which is why that can't be an answer choice. E is not an answer choice. F, 615. Is 615 between 600 and 670? Would it also fit in that range? Well, if you did that correctly, then you should be able to tell me, yes, it is an answer choice. Sorry, it is a correct answer. G. G, hopefully you knew right away, that's actually the exact same answer as letter B. So yes, G is a correct answer. Last one, H. Look carefully at letter H. If letter H is the correct answer, one of the correct answers, then it had better fall between 600 and 670. Well, that's 67. 67 thousandths is not between 600 thousandths and 670 thousandths. So letter H is not a possible solution. Okay, that was a quick review of converting fractions, decimals, and percentages. Now, read this word problem to yourself. Okay, the first thing that stands out to me, how much more money would Mandy have saved, not including tax, if she'd waited the following week? Well, how much would she have gotten off the following week? 65% off. How much did she get off the first week? 40% off. Well, those two stand out to me as pretty important pieces of information in this word problem. Mandy bought a CD for $40 off the regular price of $16. The next week, it got marked down to 65% off the regular price. How much more money would Mandy have saved? Well, hopefully you've solved it. You paused the video. You're ready to see if you got the answer right. Again, the point of this activity is to review various strategies. Here's one possible strategy you could have used. In 6th grade honors, you learned benchmarks. Benchmark percentages are an awesome strategy that don't require a lot of calculations on paper. Typically, you could get them in your head. Well, I know that 100% is the full cost, $16. I'm trying to figure out 40% and 65%. I could use that benchmark, 10%. 10% of that $16, $1.60. Well, hey, if I have 10%, I can easily get 40%, use my scale factor. Multiply by 4, 40%, $6.40. Pause and think. What question am I trying to solve? Because right away, when I look over at my answer choices, I see one of those answers. $6.40 is G. I've done a little bit of math. G could be my answer if it's the answer to how much more money would Mandy have saved. Well, question. Would Mandy have saved $6.40 or would she have spent $6.40? Hopefully you got that correct. The answer is she would have saved $6.40. How do we know? Because the word problem says that's how much she would have gotten off the regular price. Okay, well that's if the price was 40% off. Now we've got to look at, well, what about 65% off that price? Keep going with those benchmarks, keep working your way up, and you would get 65% off that price, $10.40. There's another answer choice. J. Would Mandy have paid $10.40? No, again, according to that word problem, that's how much she would have gotten off the regular price of $16. Okay, so which one of these is the answer? Is it J, $10.40, G, $6.40? Well, the question again says, how much more money would Mandy have saved? If you used your strategies, if you realized the problem, you would have said Mandy would have saved $10.40, $6.40. How much more would she have saved? Think about what they're asking you to do with both of these values. How much more says, now I need to, that's correct, subtract those two values. Subtract the two, how much more would she have saved? $4 more. So congrats if you had the right answer from the start, F, $4. Now some of you might be thinking, okay, I've got a way more efficient strategy. I hope you do. There's more than one way to solve these problems. I hope your brain came up with several different strategies. That makes you stronger. That's awesome. Here's another, not the only, but another strategy you could have used. We tried benchmark percents, but you also could have applied a little more logic and simply said, if she's going to get 65% off the next week compared to 40% off the first week, well, that's an extra savings of 25%. So all I've got to do to get this answer is find out 25% of the original price. Well, you're totally right. And 25% of that original price is $4. Much more efficient if you can think on that level. Then nice work. Well done. All right, let's keep it going. So please take about 10 seconds, read this problem to yourself. A bag of Nick's Yummy Gummies contains 26% green, 34% red, 24% white, 16% yellow. Carla put 250 gummies into a bowl altogether, total. Write a proportion that can be used to find the total number of yellow gummies. Key, write a proportion. They're not asking me how many yellow, what percent. They want to see, can I write a proportion in order to solve a question that they could ask? Well, the proportion says to find the total number of yellow gummies in the bowl. If you wrote your proportion correctly, then you compared yellow to total. It's not a part to part. I'm not comparing yellow to white, yellow to red. I want a percentage, which is a part out of 100, part to whole. Yellow is the percentage they asked me to find, so my only focus in this situation is on the yellow gummies, 16%. All right, let's see how you did with your proportion. If you wrote your proportion correctly, then your proportion says yellow to total would be 16 to 100 is equivalent to X to 250. Now, if you're thinking, oh no, my proportion doesn't look like that, mine must be wrong. Remember, there are multiple ways to write these proportions. You also could have written a proportion where you simplified the first ratio. 16 100ths can also be written as 4 25ths. So if you've got the pink one, excellent. If you have the green one, even better, because that one has been simplified. But you still might be like, mine does not match either one of those. Well, proportions are just two ratios that are equivalent to each other. I can take these two ratios and reverse them. If 16 100ths is equivalent to X over 25, then that's also the same as saying X over 25 is equivalent to 16 100ths. All three proportions would be accurate, but we really want the most simplified, which would be the green one. Okay, last. Here we go. You've done a great job solving percent problems. Your final problem, take a look at the screen, read it for yourself. All right, pause and use logic. You've got 4 people. They need to drive for 16 hours and they're supposed to split up the drive evenly. Logic should tell you, oh, okay, I know how long each person should drive. Got it. Well, somebody messed up. The first driver drove 15% longer than he should have. Question says, how long will each of the other 3 people drive if they split up the remaining time evenly? Well, the issue is he didn't drive 15 minutes longer. He drove 15% longer than he should have. Pause and think, what's your first step? What's the first thing logically you need to figure out? Okay, hopefully you said, first thing I got to figure out is how long should he have driven? Well, you probably got that from the start. 4 people, 16-hour trip. He should have driven 4 hours. Well, he didn't. He drove 15% longer than he should have. So step 2, how long is that? Well, this is where you've already been practicing this week. You know how to find 15% of 4 hours. You've got multiple strategies and ways to get that. You can write a proportion. You can convert the percent to a decimal and multiply. 15% of 4 hours is 6/10. He drove 6/10 hours longer than he should have. Well, that's still not the question I'm being asked to answer. How long will each of the other 3 people drive if they split the remaining time evenly? Logically, what's your next step? Well, that's correct. Find out, well, how much time is still left for the other people to drive. Well, he drove 4 6/10 hours. He was only supposed to drive 4. It's a 16-hour trip. 11 4/10 hours are left over for the other 3 people. Step 4. 3 people need to split that time evenly. Take that amount divided by 3. 3 8/10 hours is what's left for each person to drive. Pause and think. Is that what the question is asking me to answer? The answer is yes. They're asking me to answer, how long will the 3 remaining people drive? G, 3 hours, 3 8/10 hours.